Hey, I'm Bib and Joseph. Today I'm going to explain about different layers of OSI model in computer networks. OSI model established in 1947, International Standards Organization, a multinational body. An ISO standard covers all aspects of network communication as the open systems interconnection. An open system is a set of protocols that allows any two different systems to communicate. OSI model is to understand and design a network architecture that is flexible, robust and interoperable. There are 7 types of layers: physical layer, data link layer, network layer, transport layer, session layer, presentation layer, application layer. Physical layer. The physical layer is responsible for movements of individual bits from one hop node to the next. 1. Physical characteristics of interfaces and medium. It defines the characteristics of interface between the devices and transmission medium. It defines the type of transmission medium. 2. Representation of bits. Bits must be encoded into signals, electrical or optical, during transmission. It defines the type of encoding, how 0 single quote s and 1 single quote s are changed to signals. Data rate, number of bits sent in each second, duration of a bit, etc. 4. Synchronization of bits. Sender and receiver must use same bit rate, must be synchronized at the bit level. Sender and receiver clocks must be synchronized. 5. Line configuration. It is concerned with connection of devices to the media. In point-to-point configuration, 2 devices are connected through a dedicated link. In a multi-point configuration, a link is shared among several devices. 6. Physical topology. How devices are connected to make a network. Mesh, star, bus, ring and hybrid topologies. 7. Transmission mode. It defines direction of transmission between 2 devices, simplex, half duplex or full duplex. Data link layer. The data link layer is responsible for moving frames from one hop node to the next. Transform the physical layer to a reliable, error-free link. Data link layer. Duties. 1. Framing. It divides stream of bits received from network layer into data units called frames. 2. Physical addressing. When frames are distributed to different systems on the network, it adds a header to the frame to define sender or receiver of the frame. 3. Flow control. To regulate the flow of information, flow control mechanism must be used. 4. Error control. Detect and retransmit damaged or lost frames. Recognize duplicate frames. Error control through trailer added to the end of the frame. 5. Access control. When 2 or more devices are connected to the same link, data link layer protocols are necessary to determine which device has control over the link at any given time. Network layer. The network layer is responsible for the delivery of packets from the source host to the destination host. If 2 systems are connected to the same link, no need for a network layer. If 2 systems are attached to different networks, there is a need for network layer for the source-destination delivery. Logical addressing. If a packet passes the network boundary, another addressing system is used to distinguish between source and destination. There are 2 types of addresses, logical and physical. The physical address is the link address of the node defined by LAN or WAN. The physical address is also called as MAC, Media Access Control address, and it is generated by the manufacturer. A physical address may be known by several different names: the hardware address, an Ethernet address, or a Media Access Control (MAC) address. Another name for logical address is IP address ampersand. It is set by Internet Service Provider (ISP). Physical addresses are not enough in an internetwork environment where different networks can have different address format. A universal addressing system is needed where each host can be identified uniquely. A 32-bit address defines a host connected to the Internet. For example, 11,10,101,000,000,110,000,111 network layer adds a header to the packet which includes logical address of sender and receiver. 2. Routing. When independent networks are connected to create internetworks, the connecting devices, routers or switches, switch packets to final destination. Transport layer. The transport layer is responsible for delivery of a message from one process to another. A process is an application program running on a host. network layer does the source-to-destination delivery of individual packets. But the transport layer ensures that the whole message arrives in order, checking both flow control and error control. 1. Service point addressing, delivery of message from a specific process on one computer to a specific process on the other. The transport layer header must include a type of address called service point address or port address. 2. Segmentation and reassembly. A message is divided into transmittable segments with each segment containing a sequence number. These numbers enable the transport layer to reassemble the message correctly while arriving at the destination. It identifies and replaces packets that were lost in transmission. 3. Connection control. The transport layer can be either connectionless or connection-oriented. Connectionless transport layer treats each segment as an independent packet and delivers it to the transport layer. A connection-oriented transport layer makes a connection with the destination machine first before delivering the packets. 4. Flow control. Flow control at this layer is performed end-to-end rather than across a single link. 5. Error control. Error control at this layer is performed end-to-end rather than across a single link. Error correction is usually achieved through retransmission. Session layer. Session layer is responsible for dialogue control and synchronization. It establishes, maintains and synchronizes the interaction among communicating systems. 1. Dialogue control. Communication between two processes to take place in either half-duplex or full-duplex mode. 2. Synchronization. It allows a process to add checkpoints or synchronization points to a stream of data. Presentation layer. Presentation layer is responsible for translation, compression, and encryption. It is concerned with syntax and semantics of the information exchanged between two systems. Duties. Translation -1. Processes in two systems are usually exchanging information in the form of character strings, numbers, etc. 2. It must be changed to bit streams before transmission. Encryption. Sender transforms the original information to another form and sends the message to ensure privacy. Decryption reverses the original process to transform the message back to its original form. 3. Compression reduces the number of bits contained in the information. It is important in the transmission of multimedia such as text, audio and video. Application layer. Application layer, services network virtual terminal, a software version of a physical terminal, allows to log on to a remote host. Mail services, file transfer, access, and management directory services, provides distributed database sources and access for global information about various objects and services.